Hi guys, welcome to the lecture number 4 for the rocket propulsion, and we are going to see the new equations in our new chapter, that is the rocket performance. As you know, myself Ujjwal Srivastava, and I'm doing my master from IIT Kanpur, and these lectures are dedicatedly for the GATE 2026. Whoever is preparing for the GATE 2026, please follow this channel and please follow these lectures. You can get everything free of cost, and you can get a complete syllabus for the GATE 2026. You no need to go anywhere for the questions and anything. Please follow these lectures and channel. You will be cracking the GATE for sure. And here I have given my number, so please contact me if you need any guidance from my side, and if you need any help from my side, please feel free to contact on this number. So till now we have done till equation 5th, so let's continue. And one request guys, actually I'm in a hostel, so whatever the background music are coming or sounds are coming, please ignore that, because I cannot find the single places to ignore all these background musics and sounds. So please focus on the lectures. Do not concentrate on the background musics. So please, and one thing also, let me request one thing also. Whoever are coming for the watching the lectures, please feel free to subscribe and share with your college friends as well as your friends, whoever needs these videos. So let's continue from our next topic. So write next topic as a specific impulse. So write a specific impulse. So what is basically a specific impulse is, right? It is reciprocal of a specific propellant consumption. So let me write the equations first, then after we'll discuss what is basically a specific impulse is. So basically the ISP, it is noted as a ISP. It is nothing but it is a reciprocal of SPC, that is a specific propellant consumption. And this SPC is nothing but your force divided by, thrust divided by the mass flow rate of a propellant. So you will get as a it is a reciprocal, I think. It is basically mass flow rate of a propellant divided by the thrust. So you will get as a thrust divided by the mass flow rate of a propellant. Okay, so let me take equations first. So basically this is equation number 6. So what is the unit of this equation is Newton kg second. That means Newton second per kg. But basically in our questions we'll see the ISP is mostly or many times it is given as a second. So we'll see this when you solve the questions. So you can write also the ISP is nothing but your thrust divided by the mass flow rate of a propellant into the G is the acceleration due to gravity. So you will get as a 1 by SPC for sure. So in this equation you can get as a equation number 7, or you will get as a ISP in second, right? So you'll be confused why we'll dealing with the Newton second per kg and second. So we'll see this in a questions, when solve the questions, so we will see this concept, when to use the second and when to use the Newton second per kg as per given the data of our questions, right? So now, right, basically what does it mean, what does a specific impulse means? So right, the specific impulse means a specific propellant consumption means if we are using 1 kg of propellant, then how much thrust we are generating. Sorry, here it is not a specific, it is a specific impulse, the ISP. Fine. So how, that means how much thrust we are generating for how many times, for how many times. Let me give you example how many times, so you will get understand very clearly. Example, let's suppose if you are having the ISP is equal to 300 second, mostly it is given in the questions, right? So what does it mean? Let me tell you. It means is rocket can generate thrust for 300 seconds in 1 kg of 1 kg consumption of 1 kg consumption of propellant. That means if you are using 1 kg of propellant, that means your rocket can be generate thrust for a 300 seconds, right? That means how much thrust it will generate? It will generate around 1 kg F. So how much thrust it will generate? How much thrust it will generate? It will generate 1 kg F thrust in 1 second basically, right? So 1 kg F is nothing but your 9.81 Newton. Fine. So remember this. Write another point for the ISP. If ISP is more, what does it mean? Obviously the thrust is more, because if the ISP is more here, if the ISP is more, that means your thrust is more, or if the thrust is more, that means ISP is more, for sure. So yeah, so if ISP is more, then more thrust for sure, and fuel are used efficiently. The fuel we are using, the fuels are used efficiently, right? So whatever fuels we are using, that means that is using efficiently. That means efficiency is higher when the ISP is higher, right? When the ISP is higher, then the efficiency is higher for sure. So right, what are the things over here in the equation 7? So you can write here as a m dot p, or you can say the m dot, nothing but your mass flow rate of propellant. Fine. And this m dot p is nothing but your mass flow rate of oxidizer plus mass flow rate of a fuel. Fine. This is the mass flow rate of an oxidizer, and this is the mass flow rate of a fuel, basically. Fine. So this is the basically ISP. So basically now I'm saying, so the ISP, in the ISP the units are very important. If the units will be given in the question, Newton second per kg on second, so accordingly we need to multiply and divide this G value. So we'll see when we'll solve the questions very correctly. Now next topic as a velocity through any duct. So already we have done this, but still let me again try this. Okay. Velocity through any duct. Basically they are talking about the rocket engines. So let me draw one figure for you. Let me take this is a, guys please ignore the background music and background peoples who is talking. Still I cannot do anything for this. Okay, so let me draw this. No. Fine. Let's suppose this is your seed nozzle, or you can say the combustion chamber. So from here to here, this is your view. This is your combustion chamber in the rocket. Combustion chamber. We can do better from this. Fine. Yeah, now it is fine. This is basically combustion chamber. You can say the storage chamber also, because we have stored all these things. Storage chamber. In this combustion chamber, the velocity is 0, right? So if the velocity is 0, then all the properties are called as the stagnation properties. So this stagnation properties I am denoting here as a C. PC, that means the combustion chamber pressure. TC, that means the combustion chamber temperature. Although this PC and TC are the stagnation temperature basically, but still we are using this C term because we are using the rockets, because when we will see the not property in a gas dynamics, so that's why I'm not writing the not property over here, so that you will be confused. So that is why I'm writing the C subscript for your properties for the pressure and temperature and all these things, so that you cannot confuse. So basically these are the PC and TC are the chamber temperature, chamber pressure. That means these are all the stagnation temperature basically, right? The volume is constant obviously. Fine. This is basically your A throat, you can say, or A minimum, you can say, and for sure the nozzle will be choked, so it can be the A star also, because it is a CD nozzle. And if you go for the supersonic, obviously, because in our rocket we need to go the supersonic, so see all these things we'll see as this one. That means the rocket is going like this, this is your nozzle, right? So exhaust gases are coming like this, exhaust gases are coming like this from the nozzle. You can see when the rocket goes above the earth's surface, so you will see this, right? But we'll see how these exhaust gases coming basically in the gas dynamics, right? Then after we are having here as a PE, TE, rho E, AE, VE, all these things, right? So by we can write, and around this there is a atmospheric pressure, we can say the back pressure also. So now we write, yeah, so now write by energy equation. So basically the energy equation, whatever I'm going to write over here, this is for the open system, right? So we will study this in thermodynamics. So write H1, that means the H1, first we write formula H1 1 by 2 V1 square plus Q is equal to H2 plus 1 by 2 V2 square plus W. So there is no any heat is added to this system. That means heat is not added to this system, right? So this Q is 0, right? The work is done on the system or by the system is being done, so this W is also 0. This is the work done, right? But you know this velocity is 0 over here, so this specific enthalpy is called as a stagnation enthalpy. That means you can say it is a TC, right? So this is called as a TC because of this velocity is 0, and this H2 is nothing but your this exit velocity. That means you can say the HE plus 1 by 2 VE square, right? So now you know that the H is nothing but your Cp into T, right? This TC, that is equal to Cp into Te plus 1 by 2 V square. If you take this, so you will get as a, after some time you will get as a VA is equal to root under 2 Cp Tc minus T. So always you remember the chamber temperature will be always higher than the exit temperature, for sure. That this chamber temperature is nothing but your stagnation temperature. So it is always higher. So let me write the equation number. This equation number your, I think 8, right? This is equation number 8. Fine. Now again, let me you can remember this formula. Then after whatever I am doing, please do like this. So no, so after this you don't need to remember 2 or 3 formulas. So let me write. So the Cp is nothing but your, from your thermodynamics, gamma R by gamma minus 1. Gamma minus 1. So if you put this over here, so you will get as a V is nothing but your 2 gamma R by gamma minus 1 into Tc minus T, right? This is another equation. You can mark is also equation 9, let's suppose, right? Again, what you can do is you can take this Tc from here and you can write it is a V is nothing but your, okay, after some time let me take, okay, this 2 gamma R, let me take this Tc common. So this Tc will be gamma minus 1 is equal to 1 minus T by Tc, right? So whole power 1 by 2. All these things you can do by your autopilot because it is all things are you know, gamma R, gamma minus 1, Tc, all these things you know all this, right? So now you can write as a, okay, you can write now, you know this C star is nothing but your root Tc divided by f of gamma, right? So what you can do is, now you can understand is, see, this gamma RT, that means this Tc, you can write in terms of the C star into f of gamma, right? Because this, okay, you can take this not over here, so you will get confused. Okay. So now you can write is RTC is equal to f of gamma into c star. So you can put this over here. So we will get as a b is nothing but your c star f of gamma 2 gamma by gamma minus 1 into 1 minus t by tc. Guys, please ignore the background music because today is Sunday, so the people are very excited. So please ignore this, right? So this is another form of equation, right? All the things are at your autopilot. All things you can write by your own if you know all these things. Remember, if you remember all these previous things like CP values, then after your this C star values, you can write it by your own. So now what you can do is a VE C star f of gamma. You can write is 2 gamma by gamma minus 1 of 1 minus this t by tc. You can write is a p by pc, obviously gamma minus 1 by gamma, right? How I am writing this, please observe this, because p by pc is nothing but your gamma by gamma minus 1. That is equal to, that means p by pc is nothing but your t by tc to the power gamma by gamma minus 1. So if you bring this power term in this another term in another side, so you will get a gamma minus 1 by gamma, right? So you can this is the equation number basically of 10, or you can say 10. So basically whatever I have written from here to here, whatever I written from here to here, basically it is at autopilot. You don't need to remember all these things, right? First you remember this, then after you can write all the things which are the required over here. So if you want to remember, please remember, otherwise no need to remember all these things, fine? Then now you write from equation 5th, because what is equation 5th, you can please see, you can see this one. Let me copy this. So from equation 5th, from equation 5th, we are having this, right? We are having this. So what we can do is, let me take, if you take this m dot common, because we want to express all this in terms of ISP. If you take m dot common, so you will get as a VA plus A divided by m dot, then P minus PA. And you remember what is this m dot we have found in a first lecture, I mean here. This m dot over here is basically, yeah, this one in terms of C star here, this equation I am talking about, right? So you can write this equation as this one. So you have to write this equation because we want to express ISP in terms of C star and thrust coefficient. So we'll see this, right? So if you m dot is equal to VA plus AE divided by, or one thing you can do is you can put this AE value over here also. So let me take this, please wait for some time. Okay, it could not. Okay, take this. Fine. So these things basically we can write as a VE. Fine. Plus we can have AE divided by I'm going to write m dot as a PC A throat, or you can say A star divided by the C star into P minus PA. All the things you can write by your own. So now if you take the C star common from here, because it will go at m, so if m dot, that is nothing but your ISP nothing but your C star of f of gamma. I'm writing this term, f of gamma root under 2 gamma by gamma minus 1 by P by PC to the power gamma minus 1 by gamma. Fine. Then after we are having the plus A by AT P minus PA divided by PC. Fine. Okay, then now it's a very okay. Then now this term basically are called as the CF. Right? This call is called as CF. That is nothing but your thrust coefficient. Thrust coefficient in the rocket. Right? That means ISP you can find as a C star into CF. Right? So this is equation number your 10. You can take this equation number 11. This equation number 11 you can take. Then this equation number your 12. Fine. So what you can do is, if in the question, if they gives you C star, that means characteristic velocity, if they gives you ISP in Newton second per kg or second per kg, we'll see the when we'll solve the question. Then they can ask what is the thrust coefficient. Of course you can find. So if they will give 2 out of 3, you can find the another one, right? Okay. So now you write the thrust equation. We know that the if is nothing. Okay, let me take another one. You know that the if is nothing but your, we can say this ISP in terms of IFC if you want. ISP is nothing but your F divided by m dot. That means F is nothing but your ISP into m dot, right? You can put this ISP value over here. So F is nothing but your C star CF into m dot. Okay, this is your question number 13. Now you can put this m dot value over here. So F is nothing but your C star CF into PCAT, or you can say the A star for sure, C star. So you can cut this and we can have the CF into PC into A throat. That means CF PC into A throat. That's number 14. So now what we have done by here is basically all the things we have done for finding one equation, that is a thrust in terms of the thrust coefficient, right? So if the thrust coefficient is given, if the chamber pressure is given, if the throat area is given, if they want to find the thrust, you can find happily find. If the C star is given, if CF is given, if mass flow rate is given, you can find happily what is F. If you need to find mass flow rate, then all the things you can find from here. So please remember these formulas, because these are the very important formulas over here, right? So till now basically we have done till equation 14. So basically we have found the thrust equation in terms of the many things: thrust coefficient, characteristic equation, mass per rate, all these things we have found over here. So let me stop here over here, because it's a time for lunch for me. Mess timing is at 2 o'clock only. So let me go, then after we'll continue from the next class. And please revise till here, and whoever is coming for the watching the lectures, please subscribe the channel and like at least, because it will help both of us. So if I get some more data from your side, so I will be of course making some more videos, and I will find some more data for you. So please subscribe my channel and like and share with your college friends as well as your close friends for sure. So thank you so much. Please have patience with all the things. It is very important to have a consistent in our for your GATE exam. So thank you so much. Have a nice day.